Hello friends, in the present video, we will study how to find the earth pressure if your back wall is inclined. Let us say simply I will write it down, inclined back wall. Let us consider a retaining wall like this with inclined back wall and the soil mass is retained is truly horizontal. This is the soil mass retained. Okay, now let us say the angle here is theta. So what we have studied, if you want to study earth pressure using Rankine's theory, your back wall should be vertical and it should be smooth. But here what has happened? The back wall is inclined. That means here we cannot apply the Rankine's theory. Then how can we find the stress here, or how can we find the earth pressure? So that's why we will follow some imaginary procedure. That means first we will draw a vertical line that is parallel to the toe of the retaining wall. So from the toe of the retaining wall, let us draw a vertical line. And if you see this part, so this is part like a, imagine it like a vertical wall is here and the soil mass is retained. So because of this, you will find out the earth pressure like this. Let us imagine the magnitude is P. If either it can be active or it can be passive, it's up to your wish. But as of now, let us just remember with P. And let us say this wedge portion is A, B, C. So we have considered only this part, then what about the part ABC? Here, we will consider the weight of the mass, ABC. Let us consider the weight of the mass is weight. Now observe, P is in horizontal, W is in horizontal. Then what will be the resultant that will act on this surface? That will be somewhere act like this. So this is what nothing but a resultant of the weight and the earth pressure. Let us say this is P1. This is not exactly the earth pressure. Why? Because we are considering it as imaginary surface. So the earth pressure will be this magnitude P. How can we find out that? That will be nothing but a under the root W square plus P1 square. Is it okay? Suppose if I are representing the forces like this, P1, and if I represent this W, weight of the soil mass here, and this will be my resultant. If I find out the angle with respect to the horizontal, how can I find out that angle? I will find out it as tan alpha h, that will be equal to W divided by P1. So from this we can find out the angle alpha h. That means if your here resultant is nothing but a earth pressure. If your surface wall is truly vertical, if your back wall is truly vertical, your earth pressure will be truly horizontal direction. But if your back wall is inclined, then your earth pressure will be acting in the inclined way. With how much angle? With respect to horizontal, that will act at an angle of alpha h. That can be found out by using this relation. And whatever the magnitude of it, that will be equal to under the root W square plus P1 square. So here also we are applying the Rankine's theory, but what we are doing, the inclined portion, the soil over the inclined shape, we are considering the weight of the soil on that wedge. Now, from this, tell me what is the weight? Weight, it will be nothing but a half into, what are the dimensions? AB into BC. This is what nothing but area into unit weight. This you will get the weight of the soil mass. The P1 we can already know how to find out, that will be equal to K into sigma V. And if you know W and P1, then you can find out the pressure, the earth pressure that is acting on the inclined wall is P. Okay. So if your back wall is truly vertical, your earth pressure will be horizontal. If your back wall is inclined, your earth pressure will be inclined at an angle of alpha h. So this is what about the retaining wall if your back wall is in inclined position. Okay, thank you.